Good morning, good afternoon, and good evening, everyone. This is Dr. Samuela Guida from the International Water Association. This is the PrimeWater Multi-User Panel Stakeholder Week. This is the third day of the week, and we are focusing on potable water today. So some housekeeping rules while we wait for the last people to join. If possible, please rename yourself using your name and your company. Feel free to introduce yourself in the chat. And the meeting is being recorded. And so if you have any concern about this, please contact myself. If possible, please show your video if you want, but please mute your microphone unless you are speaking. And for each presentation of today's session, please add your question in the chat box, and if possible, indicate the person you are addressing. And note that after the meeting, you will receive the slides and the recording of the session. So as I was saying, this is the PrimeWater Multi-User Panel Stakeholders Week. What is the multi-user panel? So PrimeWater is an European project, and you will hear more about it later. And we have a multi-user panel, who is a group that serves as an international panel of user that provides who provides expert feedback on Earth observation enabled services that are developed or extended in the context of the PrimeWater project. And also the multi-user panel participates in the co-generation process through dialogue. We had the first MUP workshop in October last year, and we gather initial feedback on what different users think about different services. This year, the second MUP, we are organizing as a stakeholder week, as I was saying, and each day from the 15th until this Friday, we will focus on a different sector. We started the week with a session on water resource management. Yesterday, we focused on disaster risk management. Today, as I was saying, is potable water, and the week will follow with a session on energy and amenity recreation and aquaculture on Friday. So the main objective of the week is to provide the participants with an update on the services that PrimeWater can offer, understand how different sectors are using Earth observation services to address issues such as extreme hydrological events or harmful algal bloom. And again, to discuss the added value of the PrimeWater products when addressing these issues. So today we have a very busy agenda. We'll start with an introductory session where you will hear more about PrimeWater. Then we will have some experts providing their feedback on potable water and Earth observation services. And this will be followed by a discussion with your questions. And then we will go through the third session, where we will learn about this survey that PrimeWater has developed to assess behavioral attitudes for adopting advanced Earth observation downstream services. So without further ado, just to wake us up, I would like to ask you to please participate in this poll to indicate your sector, and if you use Earth observation technologies in your work. You should see these questions in your screen, on your screen. Perfect, thank you. And you'll see the result on your screen. The majority of you comes from other than consultancy, government organization, NGO, regulator, university, research institute. And do let us know in the chat what is that other that you are belonging to. And then if you use Earth observation in your work, yes, directly, the majority of you, yes, indirectly, and no. Perfect. Thank you so much for sharing that with us. And I think now I'll leave the floor to Andrea Virdis from Ente Acque della Sardegna. ENAS is one of the partners of the PrimeWater consortium. So Andrea, the floor is yours, and I'll give you control on the slide.
Fine, thank you. I'll show you the potential benefit that PrimeWater operational services could give to the drinking water treatment plant. And first of all, I would like to present my company, that is Ente Acque della Sardegna. That is a public company that supply raw water in Sardinia for different uses, for agriculture, for industrial, and civil purposes. We have the management of about 32 dams. Most of them are artificial dams, and in Sardinia, 80% of the water is supplied by artificial reservoir. The rest of the water comes from underground resources. The target of ENAS is to provide, to satisfy the needs of the customers, and whose requirement is to have a timely information on the water quality changes in the dams. And this is the main target that we have to solve in our mission. We provide raw water for all these users, and we sell the raw water to the integrated water service operator, that is the Abanoa Society, that has the management of the drinking water plant. We used to do this plant for about 50 years, but then now the plant is operating by this new company with the advent of the new regulation. To analyze, to check the status of quality of all the dams that we have a system that is called the territorial information system, that gathers all the information coming from the dams, from water quality, from the water quantity, gathers also the rainfall, the evaporation, the intensity, and all the sensors that gives information on water quality are collected in this database. The so-called SIPIT is used as a support decision tool for ENAS, for also the Sardinia Water Authority and the Regional Civil Protection Department. PrimeWater tools could be considered, that could be integrated this kind of control of water quality in the dams. Thanks to the Earth observation, the weather forecasting, and the forecasting of water quality, as we can see later on. One of the most important problems in Sardinia is that the water quality belongs to the eutrophic class. That means that we have a lot of phytoplankton, in particular cyanobacteria, that is a category of phytoplankton that is quite critical in the treatment, in the drinking water treatment, because it has the ability to produce toxin that can remain in the algal cell or released in the water, giving a toxic effect on the human body. Here you can see some example of the cyanotoxin that we have measured in the raw water, and the toxic element that sometimes should be found in the plant and the drinking water. Okay. One of the most important drinking water plant that we have in Sardinia is the CAGLIARI drinking water plant. That is supplied by the raw water of Flumendosa and Mulargia. That is the lake that is the case study in PrimeWater that we are going to study with this project. It's a very important plant that considering microspreading unit, microfiltration, sand filtration, and disinfection with different kinds of disinfectant, as chlorine or chlorine dioxide or ozone. The presence of raw water in algae, phytoplankton in the raw water could give a lot of problem in the drinking water plant, because we can have an increase in the water toxicity. We can increase in the chemical oxygen demand, and that means that we can have an increase in 3-alomethane THM production of chloride ion present in the disinfection as disinfectant byproducts. We can also some algae that can float instead of sedimentate. So we can have also a potential increase in clogging filters. So we have to remove this phytoplankton before entering in the drinking water plant. Here you can see also the picture that represents the system that is going to study in PrimeWater. This is the Mulargia Lake and the Flumendosa that are linked to each other and provide the water in the southern part of Sardinia, in particular in Cagliari. The total amount supplied, it's about 200 million cubic meters for civil purposes. The problem of phytoplankton is very critical in these two lakes. As you can see here, the Flumendosa Lake sometimes leaves an outbreak of algae bloom, as you can see in this picture. Sometimes the Flumendosa quality is better than Mulargia. And in other period of the year, it's changed the water quality. Mulargia is better than the Flumendosa. In the management of the water resources, we have to remove and to change the water quality to supply to the end user. For example, blending the water coming from Flumendosa and Mulargia. But it depends on the water level and on the amount, on the maximum amount that we transfer from one dams to another one. In this case, PrimeWater could help us to mitigate the problem of algae blooms. I skipped this slide because I think we have enough time. And in this picture, we can you can see how PrimeWater operational tool can work to mitigate the algae bloom effect. In this slide, you can see the evolution, the forecasting evolution of the Mulargia dams in 9 days. As you can see, Mulargia in October 10 was a good water quality, but after 9 days should become worse. Using PrimeWater tool, we can avoid such kind of situation. We can use a modeling that can simulate different kind of scenarios, how to mitigate this detrimental effect. We try to use the modelization. Okay, that has scenarios established transferring of about 40 million of cubic meter of water coming from Flumendosa into the Mulargia dam. As you can see in this slide, according to the model, we can receive an improvement of the water quality in the Mulargia. That means an improvement of the water quality supplied to the end users and to the Abanoa company that will treat the water with lesser content of algae bloom. PrimeWater in this manner demonstrate that the operational tool should give a benefit to the management of the water resources in the drinking water sector, because in this way we can give to the Abanoa society a better water quality. We can reduce in this way the cost of the treatment cost concerning the chemicals, the energy related to the backwashing filters. In the same way, we can have a benefit in the laboratory analysis campaign, because we can analyze the water of the dams according to a forthcoming bloom event, algal bloom event. So we can target the sampling campaign. I have concluded. Thank you for your attention. I hope to be in time.
You are. Thank you so much. Thank you, Andrea, again. And if you have any question for Andrea, do write in the chat. We now have a little demo on the PrimeWater operational platform.
Hello, I'm Vangelis Romas from Envis, and I'm going to make a short presentation.
Sorry.
Platform. The platform is available through a web browser.
I don't hear you.
The PrimeWater's website, or directly through the second link. This is the initial page of the platform with the 4 operational case studies of PrimeWater in Europe, United States, and Australia. The PrimeWater currently offers 4 services, which are the EO-based monitoring system, the hydrological forecasting service, and the water quality forecasting service, which is offered both by process-based and data-driven models. I will now jump to Melbourne Western Water Treatment Plant, and I will start with the EO monitoring service, which provides operational EO-based water quality products from Landsat and Sentinel missions. On the map here, we are able to see the latest available satellite image for our case study, which is for today, obtained just a few hours ago. The product shown here is chlorophyll A concentration at a resolution of 10 by 10 square meters, and by clicking on the map, we can read chlorophyll concentration at various points of interest. You may notice a gap here in the center of the map, which, as you can see in the true color image, is due to the cloud coverage. Apart from chlorophyll A, we are also able to quantify turbidity, total suspended matter, total absorption, shaking disk depth, and also a harmful algae bloom indicator, which classifies the probability of hub existence based on the presence of phycokianine pigments. Also, we are able to provide surface water temperature from Landsat. However, this product is not available in this case study due to the low resolution of Landsat at 30 by 30 square meters and the small size of the ponds, which causes a strong interference with the land boundary. However, surface water temperature is available on all the other case studies. In the calendar here, we can see the dates with available overpasses of satellites, and we can go back in time until 2015. Also, there is a useful tool for exploring the temporal variation of a parameter in a selected area. For example, in the graph here, we can see the historical turbidity values for the last 3 years at the selected point of interest. Currently, these EO-based water quality products are produced by EOMAPS processing algorithms. We also aspire to include algorithms from other remote sensing partners of PrimeWater, for example, CSIRO's processing algorithms. And we also aspire to include hyperspectral water quality products from Prisma and DESI's missions, although these products will not be available operationally, but only for historical periods. The next functionality of the platform is the hydrological forecasting service. I will now jump to Lake Hume and select the hydrology tab. This service is provided by SMHI and the worldwide HYPE model setup. In the map, we can see Lake Hume and all its upstream hydrological catchments. These two contribute directly in the lake, and if I click in one of them, I can view the hydrological forecast for 10 days ahead regarding river discharges entering the reservoir. In the graph here, we can see hintcast and forecasted values of river discharge for today and the following 10 days. Apart from river discharges, the hydrological model provides also forecasts of nutrients, nitrogen and phosphorus, and suspended sediments, and those variables are a very important input for the water quality modeling that is performed inside the reservoir. The hydrological model offers both a deterministic and probabilistic short-term forecast. If I switch to the probabilistic forecast, then we still have 10 days forecast, but this time we simulate a hydrological ensemble of 51 individual model trajectories, as you may see in the graph. So apart from the average ensemble value, we can have an estimation of possible range of values for each day, and we can calculate some useful statistics such as percentiles, which is a valuable input for quantifying and dealing with forecast uncertainty. There is also a third hydrological setup, which is available only in the European case study, which is a seasonal hydrological forecast, where we can have forecasts for up to 7 months ahead, averaged on a weekly basis. Moving further down to the modeling chain, we have reservoir water quality forecasting provided by Ente. This is the Mulargia Reservoir in Sardinia, where we have used the dell 3D suite to set up a three-dimensional hydrodynamic model coupled to an ecological model. The hydrodynamic model is forced with meteorological and hydrological input and provides us the circulation pattern inside the reservoir and water temperature for the next 7 days. The map currently displays water temperature for the top layer on a grid of 100 by 100 square meters and 20 vertical layers. By clicking on the map, we can read temperatures at each cell. We can also visualize the water velocities with these nice animated arrow traces, and of course I can move this time slider up to 7 days ahead in the future in 6 hours intervals. Actually, there is a nice tool that visualizes the evolution of the parameter in the forecasting period. For example, in the graph we are now observing the diurnal variation of temperature in the topmost layer. As I said, we are using a three-dimensional model, so apart from the top layer, we are also able to get information for any depth we would like. For example, here, in the middle layer of the reservoir, the temperature variation is not so pronounced. Values are almost identical for the forecasting period. The vertical profile of each forecasted parameter can also be viewed in a separate graph for any selected point. For example, here the model indicates that there is a thermal stratification at the selected point of the reservoir. The parameters of the water quality model include chlorophyll A, nutrients, phosphorus and nitrogen, suspended sediment and dissolved oxygen. Here I have selected chlorophyll A, and the map and the graphs are now showing chlorophyll concentration. And finally, there is a third tool that allows us to view cross-section of any simulated parameter along the two main directions of the reservoir. Both in the hydrodynamic and water quality models, we are incorporating data simulation techniques that are using satellite-based products as well as in situ measurements to correct the model state and avoid error accumulation. So with the process-based models, we are able to expand the available information that we have for our reservoirs up to 7 days ahead in the future. And compared to Earth observation, we can also have information at deeper layers and information about non-optically active parameters like nutrients. Apart from the process-based models, Ente is also employing machine learning models for forecasting chlorophyll and algae bloom events. So I will now move to our last case study, which is Lake Harsa. Data-driven models are trained for specific areas of interest presented as triangles in the map. Using meteorological forcing, forecasted nutrient fluxes from the hydrological model and are compared against EO-based chlorophyll values or even in situ measurements, since in Lake Harsa we had some nice historical time series with a large number of chlorophyll values and cyanobacteria cell counts, We are currently using three types of machine learning algorithms: Gaussian process regression, random forest, and random undersampling boosting. I will stay in the GPR model, which predicts chlorophyll A concentration only in the surface layer this time. By clicking on a point of interest, we are able to read the chlorophyll values at the current time step. Again, there is a graph that presents the time variation of the forecasted parameter. The dashed line are the hindcasted values, the continuous line are the chlorophyll values for today and the next 10 days ahead. One nice feature of the machine learning algorithms is that they can provide us with some confidence levels. So for an 80% confidence level, we can see that the predicted values of chlorophyll A concentration increase from 4 micrograms per liter to almost 20, and even higher for the 90% confidence interval. I will now jump to the random undersampling boosting algorithm to present you a different type of product we are using for bloom forecasting. So this algorithm has been trained to predict cyanobacteria cell counts, but not as a scalar quantity, but as a probability of exceedance of a specific threshold specified by WHO. And we have made this choice because we have seen that the model has a stronger skill in predicting if cyanobacteria concentration are going to be over or under the threshold of 100,000 cells per ml, rather than in quantifying exact values of cell densities. So in the graph we can see that the model predicts that for the selected point of interest and the entire forecasting horizon of 10 days, we're having a no-hub situation with a high confidence level. While if I click to this point, then we see that we still have a no-hub situation, but this time with a lower model confidence.
Perfect. Thank you so much, Evangelos. And we can now open the floor for some questions. Do let us know your question in the chat. I think there is already one question for you, Andrea. Yes, here from Laurent. I would like to know a bit more about the different actions you can perform to limit development of harmful algae bloom. You mentioned blending, but there is something else. And then second, how work your forecast system to understand the impact of those actions? So how this works to understand the impact.
Okay, do you hear me?
Yes, yes.
Okay. To reduce the impact of algae bloom in the drinking water plant, sometimes is the only solution could be blending, because all the river, we can also to prevent the growth of algae bloom, reducing the nutrients that are present in the rivers and collects of the water in the dams. But this is a problem that should be solved by other organizations. In our dams, when we have such kind of algae blooms, we cannot do nothing at the moment. We have just to prevent the algae bloom growth, for example, using the PrimeWater tool through the Earth observation forecasting. But when we have such kind of high content of algae, we have to advise, we have to said to integrate the water system operator that he will reach a high content of the phytoplankton. In this way, the operator will change the process in the drinking water plant. Maybe he can operate with a microstreaming unit to remove in the entrance of the plant the phytoplankton present. But we don't have so much tools to prevent and to avoid the algae blooms, because they happen suddenly. Sometimes 10 days before the water it's good, but if there is a change of weather condition, it could happen that algae blooms suddenly outbreaks in the dam.
Thank you, Andrea. And I see Tapas, you have your hand on.
Thank you, Andrea. That's a good presentation. My question is about toxins. Do you test toxins?
Yes, it's not my duty to analyze toxin, but Ente, our company has a biological laboratory that has analyzed not only the chlorophyll content present in the raw water, but analyze each species of algae present in the water, and has an instrument, I don't know which is, that analyzes the toxin, the potential toxin. Doesn't analyze the toxin, but analyzes the potential toxicity of the water related to the phytoplankton present in the water. It's a not direct analysis. It's in use, I think, Daphnia magna. It's an organic bacteria that if the water is toxic, but we don't analyze directly the toxin in the raw water.
And your species that I could see is dominated by microcystis?
Yes. Yes.
So it
yes.
will be microcystin, and there is a World Health Organization limit of 1 microgram per liter. So
yes.
I would think that before you supply reticulated water, you do check the microcystin concentration.
Absolutely, water. Yes. We have to check this water, and the result that sometimes in the raw water we have microcystin, but the complete treatment that considered not only sand filters but also carbon filters and ozonation, and in the outlet of the drinking water plant, fortunately the microcystin is completely removed.
Thank you. And the last one, between those two reservoirs, what is the temperature difference? If I look at water temperature, surface water temperature.
The surface water temperatures change along the day, but the surface should be about 20 degrees.
So both the reservoirs do have a similar surface temperature.
A little bit. Flumendosa Reservoir is upper than Mulargia Reservoir.
So there'll be colder water.
A little bit, but not so high, because they are very close to each other. So the difference in temperature is not so high.
Okay, all right. Thank you very much.
You're welcome.
Thank you, Tapas. Thank you, Andrea. I have a question for Evangelos. And this is, how long historical data sets are required for the training of the machine learning models?
Maybe now, can you hear
us? Yes,
yes.
Thank you.
Yes, yes. Great. We were saying that perhaps I could take this question. This is Kyriakos Andris. Well, this question is actually highly relevant because it is closely related to whether we can develop such data-driven solutions or not. So, given the complexity of the problem that we have to simulate with such data-oriented solutions, typical rule of thumb is that we would require 150 observational data. When it comes to satellite imagery that corresponds to this number of observations, this can be translated into roughly a 5 or 6 year long period of EO, Earth observation derived attributes. So this is just a typical assessment of the quantity of data required to have a meaningful and accurate development of data-driven solutions. Nearly 150 observations are required, which corresponds to these 5 to 6 year long periods. And I think that's the essence of utilizing EO-based solutions. It can give you the access to such long historical data sets, regardless of whether you are in, they are available at a global scale. They do not require, having a large, having access to a large database of in situ measurements or so.
Thank you. I think we have just time for one question, one other question, and it's what models are you using in the three-dimensional water quality forecasting?
Okay, well, for the reservoir modeling, we are using the DEL 3D suite, which is provided by Deltares. This is an open source suite of models, very familiar to modelers. And specifically, we are using two modules of this suite, the DEL 3D flow for the hydrodynamic modeling and the DEL 3D WAC for the water quality modeling. Both models are three-dimensional, so we typically run them in a 100 by 100 cell size, and the reservoir is discretized in vertical layers, about 10 to 20, depending on the depth of the reservoir. And first, we run the hydrodynamic model to resolve the circulation pattern and the water temperature, and then we couple this model to the water quality model, which uses additional information about nutrient fluxes and is able to resolve the trophic status of the reservoir by simulating parameters like chlorophyll, nutrient, sediment, and dissolved oxygen.
Perfect. Thank you. So thank you both for your very interesting presentations. We have a 5 minutes break now. So it's 8:40 in London. So we can be back at 8:45. That's okay. So in 5 minutes. And then we'll move to session 2, where we will have speakers presenting and a moderated discussion. Okay. All right, everyone, I hope you're back from the break. We'll now move into session 2. As I was saying, we will have experts, speakers, and a moderated discussion. During the presentation, please do put your questions in the chat. And I'll give the floor to Catherine Cross, who will be moderating this session. Catherine, the floor is yours.
Okay, thank you very much, Samuela. So we have 2 presenters today who are going to give their perspectives on Earth observation and potable water. So our first presenter is Claudia Guerrero, with Acque, and she's going to be talking about Earth observation in water safety planning. So Claudia is the head of projects and innovation and water quality at Acque, and she has a background in innovation and water quality, and her area of expertise is focused on water supply system risk assessment through the implementation of water safety plans. And as the head of the project and innovation, she's coordinates projects aiming to develop partnerships with R&D centers. So it's great to hear from her today. She's very passionate about innovation in the water sector, and we look forward to our presentation. So over to you, Claudia.
Hello, Catherine. Good morning. Good morning, everyone. So I'd like to share with you our perspective about Earth observation in water safety plans, because and just to say that just give me a second here. We are having a Teams issue and I can't mute it. I think it's done now. So sorry. We are struggling with Teams meetings and common spaces. It's a common issue today. So getting back to the meeting. And I was saying that our presentation and looking at what I could share with you, I would say that it's a different perspective. And I heard Anna talking and talking about the bulk. In the end, was bulk entities issues. Nowadays, when we look at our activity, we're going to take a different perspective from the consumer, from the tap to the bulk water, and this is quite a different angle. And in the end of the day, it's talking about perception of how water is perceived and its value. So let me see if I can manage here. So we're going to talk about just a quick, brief introduction. What is Acque Group and what's like implementing a water safety plan, but in this perspective that they are approaching, and how it is Earth observation as a tool to overcome these challenges. So, in a quick overview, so Acque is a group that manages water utilities throughout Portugal. Portugal being quite a small country, but very different in what concerns to water quality, from the shoreline to the interior line. We also have some activities in Saudi Arabia and Africa, but to the point that it's not quite relevant. So looking at our infrastructure, and to say that we have a different perspective, because we can look as bulk utilities. We have 8 water treatment plants, so we have bulk utilities, and we also have downstream utilities that provide water directly to the consumer. Also, we have 80 wastewater treatment plants, which gives us a perspective and special concerns related to discharge and the river's quality and its discharge compliance. So it's another kind of, it's a global perspective over the basin and the water resources. So when we implement a water safety plan in a utility, in being Acque a private owner, we are mostly focused on consumer confidence. Apart from other health issues and the improvement of quality of service that obviously are present there, and increased system resilience. So we have to assure technical ability and to perform at high level, but also we have to pass to our consumers the trust in our management. So for us, the reliability of the system is everything, and our ability to prove that we are reliable is everything. So having this perspective, we have to understand in the first stage at what risk we are exposed, and how can we step by step, looking from the water abstraction to the consumer, how can we reduce the risks that we are exposed. And then we have to identify what kind of controls do we need and redundancies in order to reduce that risk, and then to further identify investments. So in this case, what Acque did is we developed our own risk assessment tool, where we incorporated databases and all sorts of information that contributes us to have a picture of the system and its risks. And we did that by creating portfolios. Well, we first had a project where we implemented water safety plans in Excel spreadsheets, and then we gathered information of all our 14 municipalities, and then we created databases. And from those databases, we now have a whole set, stage by stage, dangerous events that are likely to happen, and the associated dangers. And by combination, we can have the primary risk assessment, and then we can incorporate control measures and follow through the planning. So in this stage, we would have like historical events that could happen, and apart from the context and what is happening in the water, we can project scenarios and how would the system react. And by that, we would have this whole set of risks. Some are the risk classification, and then we would approach the higher risks. So when we take that into consideration, we have to, the risks itself, we have to consider how probable of occurrence are some sort of risks. And in this case, we would have to look at analysis results. just a few minutes ago, we were talking about what was happening on the reservoirs, and if we had algae blooms. The question is, and apart from our management, how does that problem in the abstraction point translates to the consumer, and how resilient are we in managing the system in order not to occur? So when we look at the water safety plan, we look at the analysis on the consumer tap, and we try to establish how likely it is to happen. So we have this matrix where we establish our assumptions if there is something that is happening on the taps and on regulatory control, or in operational monitoring, if we think that it is likely to happen on a consumer tap due to some issue that occurs in the reservoir. For instance, how likely it is to have algae on the consumer tap if we understand that on the reservoir algae is growing. So we establish that likelihood, that probability level on a scale of 1 to 5, and then we translate that into the water safety planning. But that is what concerns the dangers itself, that we can easily audit and understand if it happens or not. And even though it may be probable of happening, then we can have control measures in water treatment plants that allow us to reduce the risk and assure water quality on the consumer tap. But what regards events, I said we had that database of historical events, but how can we understand what is going to happen, and how sure are we about what's going to happen in the nearby future? So this is where Earth observation can become as a valuable tool to overcome challenges. And just to give you here a quick example, from one of our installations in Águas do Voga. Well, Águas do Voga has a water treatment plant just by a highway, and the highway was constructed afterwards, but that's a different issue. And as you see in the picture on the right-hand side, we have two water abstraction points from the river. Águas do Voga has a water safety plan implemented several years ago, and it considers the context of the historical context given by the water samples throughout the years, and the likelihood of events that can occur considering it's a river. So now, reflecting upon Earth observation tools and how can it be advantage for a utility like Águas do Voga, if we look at River Voga, and well, you can see in the picture that snaky line, that's the highway, but River Voga along follows the highway. We have 3 cities that, well, aren't big cities like Lisbon, but they are relevant cities, and you have all sorts of contaminants coming from those cities. You have industry, you have wastewater treatment plants, you have a lot of probable events that can occur downstream, down the river, when we have that arrow that indicates our water treatment plant and intake. So we are we are obviously exposed to what happens upstream, and having those 3 major cities with relevant population and industrial activity is highly likely that we are going to have some events that allow us to need to correct our water treatment system. Well, we have probes, we have online probes that help us to understand that if we have a problem. We also have analysis that makes us understand, for instance, if the algae concentration on a river is growing. But what about human activity? What about illegal discharges? What about events that are happening in a specific time frame that could have impact down the river? Let's say if something happens here in São Pedro do Sul, in São Pedro do Sul, that is on the right-hand side, it would take some time to arrive to Albergaria, where is our water treatment plant. But it would be possible to watch it as it happens if we had Earth observation in a very real-time manner. So we would see the problem approaching, or illegal discharges. We would see impact. It would allow us to react in a different manner. And to say, to say that this downstream contamination that concerns us are mostly about the activity from the cities, and it's especially related to water treatment plants, municipal water treatment plants, because sometimes you have operational failures, and the issue is not the failure itself, but it is what you have to do downstream to compensate that in your water treatment plant in order to provide safe water for populations. And especially because in that region we have high density of shoe and textile industries, or obviously our industrial effluents, we have that in concern, the likelihood of that kind of events. And the illegal discharges, because although industries have water treatment plants, some of them may not have the most correct behaviors, and sometimes we may have illegal discharges either from industries or from populations that start implementing small businesses and don't want to have the cost of comply for discharge. So in this case, and looking at Águas do Voga and its water treatment plant, well, I'm so sorry that this is in Portuguese, but I was with a bit of a time constraint. So we could adjust the process along, because we have all the stages that are necessary for a resilient water treatment plant. And we have ozone, we have coagulation, flocculation, we have flotation, because it's a superficial water, and then we have intermediate oxidation, pH or chalcocarbonic equilibrium of the water, so pH correction also, and then we would have disinfection by chlorine. So in this case, we would have the ability to adjust oxidation, for instance, or intermediate oxidation, or even to adjust coagulation. We also have carbon activated filters. So considering this is a very resilient water treatment plant, knowing what was happened upstream before it arrived at the station would be highly relevant. And in this case, Earth observation would be quite helpful. So how can you contribute to risk management? Well, I was thinking about here a transversal concept. I would say that the most relevant aspect would be basin stakeholder accountability, because we look at a basin, a river basin, and we have all upstream issues, and we have downstream costs. In the end, what happens? We have to adjust. We can adjust our systems, but that comes with a cost. So it would be fair in a sustainable view of the system, of environmental compliance, social responsibility, but we are all talking about accountability. So not river, but basin accountability, basin stakeholder accountability is the main issue. And in this case, I would say that the authorities can represent here a relevant role, because although yeah, I suppose this is like it's something that happens in Europe, but not only. The perceived value of water isn't translated in the cost that, or in the perception of the cost that is necessary to comply and to provide safe water, not in an individual kind of perspective. People understand that they open the tap and the water should be fine, and it's a universal right, but what is the impact of that, the economical impact, and what happens upstream? How does that impact downstream? And when explaining this to someone, if someone pollutes upstream and I have to spend more on activated carbon, in the long run, the water would be more expensive, for instance, in a simplified perspective. So I would say that Earth observation would allow us not only to manage at the bulk entity level. Obviously, we have to manage that to provide water treatment plants downstream, but also to identify situations and then to apply penalties and a policy of polluter pay taxes, because at least in Portugal, industries and have to provide analysis, but they are quarterly analyses in most cases and for a few parameters. But who's looking at the river when they are discharging in the middle of the night or middle of the day? So I would say that Earth observation, as for us utilities, it's quite simple to understand the value when we look at the dam and we see at the reservoir and we see that the water quality is changing and we need to treat. But how does that translate into policies and into prevent contamination? Because in the end, reservoirs should be preserved from diffuse contamination or from direct contamination. And I would say that Earth observation would be highly valuable by utilities and by all stakeholders if it was connected to accountable terms. So I would say that this is the main key.
Okay, thank you so much.
In our perspective.
Yeah, thank you so much, Claudia. It was really, really good to have your perspective. So if you have questions, please, can you put them in the chat? We'll do the second presentation and then we'll have a Q&A at the end. So the second presentation is from Clara Ram with the Chamber of Economy, with Euro. And I'll just give a bit of her bio. So Clara has been associated with the environmental protection sector, especially water and wastewater management. She's been cooperating with the Chamber of Commerce Polish Waterworks, which is what she's going to be talking about today. And she's been involved in implementing a variety of national and international projects related to water management. So I'd like to give the floor to Clara, and we look forward to hearing her perspectives. Thank you.
Thank you, and thank you for the invitation. So a few words about Euro, which I represent, is the Federation of Water Services of almost all EU countries and some EFTA countries. We represent both public and private sector and a lot of direct jobs. So our objectives are ensuring access to water and sanitation services, protecting water resources, and promoting the sustainable use of resources, especially through the circular economy solutions. So when we are talking about main problems of water suppliers, we can talk about quantitative and qualitative issues. The amount of available water is related to climate change and civilization pressure, and more extreme weather events, floods and drought pose challenges to water supply systems. For example, in Wrocław, in Polish city, water is transferred between two rivers. During dry period, there is no water in the river that was normally used, and in addition, in periods of low flows, its quality makes impossible to take water for consumption. So that is why a system of water transfer between rivers was built, and the retention reservoir enables its storage. System control is based on weather forecasts. Perhaps Earth observation systems would facilitate the control of such systems, which are dependent on weather phenomena in remote locations. The second issue are micropollutants. So micropollution is the main problem of water quality, obviously. Water resources are exposed to more and more anthropogenic pollution, and Euro really treated very seriously. We issued a lot of papers and position papers and notes about micropollutant in the aquatic environment. In addition, the new Drinking Water Directive introduces an obligation to monitor new parameters. Thus, endorsing disrupting compounds appeared on the obligatory monitoring and on the watch list. So early warning systems for the flow of pollutants would allow to adjust the operation of the drinking water treatment plant for changing conditions. When we talk about micropollution, we have to talk about agriculture, and agricultural pollutants such as pesticides and biogens are a serious threat for water resources. They are very difficult to control. So it seems that the observation of large areas, thanks to, for example, satellite infrastructure, could be an effective solution. Observation of agricultural areas is in conjunction with weather data enables early warning of surface water users. and factor influencing the quality of water flowing out of field include the geological structure of the ground, topography, the way of managing the catchment area and land. So a lot of factors like grassland, forest areas, swamps and wetlands, type of soil also as well. So a lot of factors that influence this agricultural flow. The problem is clearly seen in example of algae blooms, as you can see on the picture from the Netherlands, but it was already mentioned in a lot of presentation yesterday and today that algae blooms are really a serious problem. Maybe not a main, but really serious problems for water utilities. This is usually due to eutrophication induced by agricultural runoff, and in the new drinking water directive, there is an obligation to test all our microcysteine in water. So, as you know, microcysteines belongs to the group of hepatotoxins and are produced by cyanobacteria in water. So these toxins are highly poisonous to humans and animals. So the observation of agricultural activity in conjunction with data on rainfall and surface runoff could enable early warning of algae bloom, as was already mentioned in previous presentations. So urban runoff is an important source of water pollution as well. And water utilities try to manage this problem, for example, by reducing stormwater outflow. Adequate data on land construction, land use, and weather phenomena are key to good planning to minimize this pollution. And for example, the NOAH project, financed from Interreg, was launched with the aim of protecting the Baltic Sea from untreated wastewater spillages during flood events in urban areas. In the process of creating this NOAH concept, the method of storm water management, spatial planning, and real-time control of urban drainage system were tested in selected pilot areas. So again, it turns out that the data is missing. It was already mentioned yesterday. The data is missing, and about flows and also weather data. I would like also to share with you the issue of degraded surfaces. So water management is particularly difficult in brownfields. The problem will worsen, for example, in Silesia, Polish region, mining area, where there has been a perforation of aquifers, disturbance of balance of groundwater, uncontrolled movement of pollutants from deeper to shallower layers. So many years of pumping mine water has disturbed the balance of water resources, and the effect of the flooding of mine are very diverse, as you see. So it's groundwater outflows from research boreholes, wells, and drift, the formation of floodplains, but also the return of waters to the natural channels of the right water courses, but also backwaters or even floods caused by the outflow of water from the channels, depressed due to, and also disappearance or reduction of water flow in water courses, and also the main problem is deterioration of water quality in submerged workings. So water pH and high content on sulfate and metals also, like ferrum or plomb. And it's also, they have an impact on underground and surface water intakes in the area. So I wonder if Earth observation data could help reduce these problems. How can we help with water balance and also with pollution migration, also underground? But a very difficult challenge is not only to obtain data, but also to process them. Data mining presents many new challenges. For example, in Prague, in Czech Republic, attempts are made to detect leaks to water supply network by using satellite data. However, you need the tools and competencies to process large amount of data. Satellite leak detection is a novel solution that enables water companies to monitor entire distribution systems in an accurate and systematic way without installing equipment to existing infrastructure. So this technology uses multispectral area imaging taken from satellites. So it's very innovative, but very interesting solution for water utilities. So the question is how to continue research for water resources. And as a representative of the Mission Board on Healthy Waters, ocean, seas, inland waters, I would like to highlight the European missions, and they are a new instrument of the Horizon Europe program to bring concrete solutions to the greatest challenges. One of them is protecting all waters, so ocean, seas, and inland water. And I am a part of this mission, and the objective of the mission is to restore the health of our ocean and waters by 2030. Restoring means to protect and restore marine and freshwater biodiversity and ecosystems, to reduce pollution, and to make the blue economy carbon neutral. I think that the interesting thing is this project is digital ocean and water and is digital twin, and also the public mobilization and engagement, which are very interesting goals and very interesting sub-projects. So as you can see, there is a lot of new challenges and challenges and opportunities for cooperation are still ahead of us. Thank you.
Great. Thank you very much, Clara. Thank you for that presentation and some of your thoughts and perspectives. So we actually have quite a few questions. So I'll start with a question for Claudia, and I'll just ask the speakers just to keep their responses quite short so we can get through all the questions. If you have, I'll just mention to participants, if you have more questions, please just put them in the chat. So one question that we have is for Claudia. So the real-time probes that you mentioned being used in the water treatment plant, how often, so what are the real-time probes and how often are you experiencing algal blooms?
Well, I was looking at the questions that arise, and I believe I can answer with an answer to answer all of them. We have simple probes. In this case, we analyze pH, redox potential, and turbidity. Obviously, in order to reduce risk, we would need to have more complex probes and eventually online spectrophotometers to analyze contaminants, because our risk assessment is based on historical analysis, and they, in the best case scenario, they are performed once a week or once each 2 weeks. So it's far less than we would appreciate. But the economical perspective is the real issue here, concerns there's observation, analysis, or probes. So I would say that the path that could evolve from this is to look at hydric management in a stakeholders' point of view, because if all stakeholders contribute for the evaluation, upstream, downstream to the consumer, and they all contribute for data creation, data analysis, the cost would be further less. So I would say that the transitioning from a utility management perspective for basin perspective would increase our ability to look at systems.
Yeah, having the systems approach gives you a better overview of where the issues are. We have a couple of questions from Arjun, and one of your, Arjun, maybe you want to say it, but I just noted you have a question for Clara about the leak detection. You can just unmute yourself and ask. Okay, we can't hear you. I can just say it. So the question, Clara, I'm not sure. Yeah, so it's, do you have any information on whether what you were talking about in terms of leak detection, is it all terrains of water distribution networks? Do you have any information on that?
So I know that there are some companies that are trying it, as Suez, for example, but they try this solution rather in flat areas. So that's why it was that Prague was chosen. So I'm not sure if every terrain if it is possible to use it everywhere. I have no precision. It's just very novel solution. So maybe we should try it in more difficult terrain that's just Prague or flat areas.
Yeah, thank you so much, Clara. This technology is really nice, but I really wanted to know whether it can be utilized in all kind of terrains, because in my field expertise, I have observed identifying leak in the distribution networks in many terrains is not that easy, despite we go on the field work. When you're propagating this technology, if it is capable of anyone can recognize this leak in any distribution network of different terrains, then we can save a lot of costs in developing nations and the projects that and the funding what happens. So this is really a good thing, and I think research should be focused on all kind of terrains. That will be very beneficial.
One thing which should be mentioned is that you need a lot of data, so you need also rather excellent GIS system just to have the twin of your network, digital twin. So it's challenging, but a very perspective solution.
Yeah, thank you.
Thank you for that. Tapas, you also had a question. You could just unmute yourself and ask.
Oh, thank you, Catherine. I'm just wondering if you have time for the question. If it is, then my question again to Claudia. Claudia, as we know that any sensor, particularly the Earth observation, is as good as it is calibrated with the ground sensor. So that's what I ask you that question. What sort of sensor do you have, and how good the sensors are, and have you calibrated those sensors that you are using there? That's number one. Number two, my question was algal blooms. I'm just wondering that maybe in Portugal, in that area, you do get quite regular algal blooms, and if so, is there a treatment in place, or it is just the activated carbon or things like that you pass the water through? Do you do any toxin testing? Do you monitor toxin sort of things? That would be my last question.
Starting from the end, we do toxin tests. We start to have algae problems from mid-April to September. What we do is that we analyze phytoplankton, we identify the species, and then according to the species, we search for the associated toxins. So sometimes we search for microcystins only, sometimes for toxins also. It depends on the species that we find. Relating to the probes and the online analysis that we have, they are quite simple. We don't use Earth observation for now, apart from, and when I answered in the query, indirect observation. For instance, when we start the first risk evaluation, we look in Google what kind of industries we have, the ones that we know, and the ones that we think that can contribute. In Portugal, we lack the share information, global share information between utilities and between stakeholders. In several angles, everyone analyzes water and the reservoirs, and we have data throughout the country, but we don't have a global database that integrates all sources of information that would allow us all to benefit. That could be a first step between increasing our level of awareness. But to say that the sensors that we have, they are calibrated, but they are very simple. As I said, we have potential redox potential, we have turbidity, and we have pH. So, and if we had online spectrophotometers, that would be highly expensive, considering that upstream the control is quarterly. So we would have to adjust our level of information throughout all the basins. That would make sense, or at least for us.
So I have a question for both, because we only have 2 more minutes left of the session. So perhaps this question is for both Claudia and Clara. And because you were talking about like the potential of using Earth observation, and Claudia, you just touched on some of the issues around that. So for both of you, what are some of the key barriers for using Earth observation in the water sector in areas that you work, and how do you think they can be overcome? What needs to be done, maybe from a technical or a policy or economic perspective? So it's quite a big question, but we'd like to get your thoughts on that. So maybe Clara, if you want to answer first, and then Claudia.
Yes, so error preservation is very prospective solution, but water utilities are rather clients for these services, so they don't do it themselves, yes, but they buy data, or they buy just services like leak detection. So it's the one thing that we need data, but we need treated data. So it is also impossible for water utilities, for most water utilities, maybe not the biggest one, but most of them are very small, and they are not able to treat data. So they need really treated data and the solution they need. But I think that the most challenging and the most needed is tracing pollutants. So if Earth observation could just detect the migration of micropollutants in the environment, especially in waters, it will be every time very welcome, because we really need early warning systems which will inform us where micropollutants are, and just we could prepare to treat them properly. And we also could find the host of this pollution, yes, which is also very important.
Yeah, exactly. And Claudia, maybe you can give 30 seconds on your thoughts on this question.
I would say that it's like cell phones in the past. We are at this point that we understand that this technology is highly valuable in our area, but to the moment it is quite expensive for the kind of usage that utilities can take advantage of. So I would say that technologically we would have to increase or to reduce those constraints regarding accuracy and how it's applied, so that anyone can use it in its own context, and then you have more engagement to the technology. And if we have some cost participation from the stakeholder point of view, and cost would no longer be an issue, then you would have other kinds of utilizations, of usage. So to say that it's like cell phone evolution. We are in the beginning of something that would evolve, and sometimes it's going to take to overcome several stages, several challenges that we have in technical level, data analysis level, and implementation level. Because for now, I suppose that the greater barrier for implementation in novel manner is the financial sustainability. Because the data the way that satellites produce data and how is it analyzed, because leakage for us would be important if we wouldn't perceive in an hour, but after a few days or one day, even someone already calls us, because in urban areas it's different, and we can perceive the leakage in a, what happens is that we have alternative methods that in a specific time frame are adequate for now. When Earth observation allows us to extract value at I would say at the relevant speed, it would be payable in the first point. We would be willing to pay, but as technology advances, it would be universal. So I would say just a question of time in solving problems.
Great. Yeah, thank you for that perspective. It's definitely an evolution. Okay, so I'll hand back to Samuela because I think we're going to have a very short break, and then we'll go to another exercise, another session. Sorry.
Yes, thank you, Catherine. Thank you, Claudia, and thank you, Clara. Thank you to all the attendees for the questions. We will now go through a short break, 5 minutes once again, and then we'll go through session 3. So it's 9:28 in the UK, so we'll be back at 9:33. Thank you all. Okay, so we now move to session 3, user preferences for Earth observation services. I put a link in the chat of a survey that we will talk about during this session. I'll give the floor to Nikos, who will guide us through the survey. Nikos, the floor is yours.
Thank you, Samuela. Good morning, everybody. Thank you for interesting presentations. Here, PrimeWater is using this survey. Many of you already talked about the feedback and interaction with the users. So this is our approach to user preferences for Earth observation services. So this I'm doing this in collaboration with my colleague Lara Agnoli from the Burgundy School of Business in France. So I will explain briefly what is our aim. We will start the survey, and I will beg you to please go until the end, because only completed surveys are usable. And I will also explain a little bit what kind of questions you will find in the survey, so it's made a bit clearer and easier for you to understand how much you help us when you do this survey complete. We will talk about attitudes towards satellite-derived water quality products, and this is one of our main aims here. We want to identify obstacles and drivers, as you may imagine, in adopting and choosing these products. But especially we would like also to somehow quantify the bundle of characteristics that could be included in those services and how much the users appreciate one in relation to the other, including usage or access pricing. To start with, there is a set of questions which are very easy, very standard, and please stop in the question, how long have you been working for this business organization?
We will give you for these about 5 minutes. So please go to the link that is now in the chat, and you'll see a survey appearing. Go down and click on next, and fill the first, I think, 7 questions.
So before we go to the next questions, where you will have some choices, please forget for a minute water, and let's talk about wine. So imagine that you have the following 4 wines, and you have to choose one. So there's bottle 1, you see the label and the price. Bottle 2, label and the price. 3, label and the price, and 4, label and the price. And then you will see a link in the chat where you will go and complete your own choices. This will help you to be part of this type of methodology that we're using.
And we also have another question here, which is, what is the more important characteristic driving your choice? Should I go through this?
Yes, please.
Okay, we can go back to the presentation. Thank you all.
Thank you.
So this was, again, to understand the questions that will be asked during the survey. And I think Nikos will give us a bit more.
Yeah. So once you have done those choices, it's not only about aggregating what you said that were their choice drivers or what you actually chose. Actually, by the way, this is an anonymous survey, and it's not so much about the raw data about people's choices or about what they have declared here, but this is useful information to go to the next step. So here you will be asked to do a similar exercise. Actually, you will have the option of none of them. And this is for monitoring services. So it's water quality and quantity monitoring services. And then you have three options, 1, 2, and 3. It will give different compositions concerning image resolution, the offered Earth observation-based water quality parameter, the offered parameter representation, the frequency with which you receive, so there are samples, 2 or 3 samples per week or 1 sample per week, and even there are prices per sample. So in this choice, you would have to choose option 1, option 2, option 3, or none of them. Okay, and this is going to be about the monitoring. And now we go to the forecasting services, and the choice is very similar. It's option 1, 2, and 3, but it's about forecasting services. You have the model parameter, the forecast horizon. So is it sub-daily? Is it 1 month ahead? Then you have the temporal spatial resolution, and then you will have the estimated price of forecasting services per year in euros and dollars. And again, you have the option 1, 2, 3, or none of them. Okay, so you will have to do this kind of questions until the end. And let's take again the wine example. And you rate the level of agreement with the following statements. So with the statement, wine is good for my health, wine is sociable and fun. Most people who are important to me think I should not drink wine, and I will buy a bottle of wine this week. So this is people give the level of agreement with the following statements. They also offer an aggregate or an average of what they think with respect to these statements. How much do they agree? So for example, many people think that wine is sociable and fun, and also they're thinking to buy a bottle of wine this week. And even some people think it's good for your health, and very little agreement with I should not drink wine. Most people are important to me. So I think we get the feeling, but so how we use this kind of data. So in this kind of data, of course, everybody focuses a lot on how you aggregate and how you responded to each question, but considering all the questions together allow us to understand how from your individual attitudes and from some perceived subjective norms that may be internalized or coming from your environment, determine your intention, and then from your intention, your behavior. So when this happens, we have a better understanding, more structural knowledge of how you go from the individuals and all the things that may affect your decisions to the behavior. And this will help us assess better and model better possible ways to make these services better and more valuable, both in the composition, but even in the valuation of the one who is providing them. So, yeah. I can go to the next slide. So we will ask you questions about familiarity, trust, attitudes, knowledge of those services. You have to remember it's anonymous. There are not right or wrong answers. We really want to capture the heterogeneity of the users, so we don't think that everybody should say similar things. Actually, this would not be very helpful. So we want to map the heterogeneity of people's preferences on the possibility of offerings that these services will be provided with. So please take the survey and also receive, once you complete it, a 10% discount for membership in the International Water Association.
Perfect. Thank you so much, Nikos. And there is a
This
comment
is true.
in the chat.
Yeah. Yes, this is true, Claudia, but we take care of this. Yes, of course, they condition, but they have been mixed in a way that they capture the elements and they are not correlated. So in the whole population, this is what you just said. It's not going to be, it's not going to be a problem, but it's going to be a source of information. So yes, you're totally right that we take into consideration the choices together with the available options. So thank you very much for this observation. This is exactly the technique. So actually not everybody is faced with exactly the same offerings and the same alternatives. So in the population, this is going to be offering us information, not biasing it. But thank you very much. Yes, you're right.
Thank you, Nikos. Thank you, attendees. And please do reach the end of the survey. I put the link again in the chat. And as Nikos was saying, this will really help us to make our services more valuable. So I'll now give the floor to Apostolis for some concluding remarks. So Apostolis, if you can come on screen. And once again, thank you all for your participation. Apostolis, the floor is yours.
Thank you, Samuela. Thank you all, our valuable speakers and all the attendees of this workshop. Your contribution, your feedback is valuable, and I'll just pick up this wrapping up concluding session from the end. This let's say experiment, the scientific experiment, I would describe it, but just a while ago Nikos presented us. So we really try we really have set up here a methodology in trying to quantify how we, all of us, reach to the end decision towards Earth observation technologies. So your contribution on that is really valuable. So please fill in, if possible, this survey, and also feel free to circulate the survey also through your networks, through your colleagues. It is important to have heterogeneity, as Nikos mentioned, and a large number of responses. And also to say here at this point that obviously the results that will come out of this analysis, this experiment, obviously will be communicated to you, in organizations, and we have a high expectation for this outcome. Now, just to summarizing what the key points that I've picked up in today's very interesting workshop, And I'll start from what Clara gave us with her presentation, and that was a very comprehensive overview of the challenges that water utilities face, and where Earth observations can actually have space, some room, can have some room and a role to play. So that was a very interesting presentation, and we thank her for that. Another issue that I'm picking up is that what Claudia mentioned about basing stakeholders' accountability and responsibility, which is a very, very important aspect. However, these considering these tedious task to overcome, taking actions to all the other downstream levels that might be at the reservoir level, or even in the treatment plant level, or even within the consumption, becomes very critical as well, as Claudia described, in order to secure high quality water in the consumption. So again, there discussion on how observations can consist in these, let's say, different levels is open. I can see that there is a technological transformation that is taking place, and I think that was clear from the discussion. Still, there are concerns, there are challenges in terms of financial sustainability, technological challenges, but yet there is let's say there are good possibilities for these technologies that are Earth observation related and supported to play a role within the sector and improve its operations. And I think what and I leave that at the end, and I think what Andrea described and presented on how intelligent services that combine satellite images, modeling perspectives, and let's say insights that comes from their own utilities and the way that they operate, all this together can provide plausible solutions to optimize operations in providing good quality, high quality water in downstream uses. So by saying that, again, I'd like to thank you all for joining this workshop. This is an open discussion for PrimeWater that we intend to keep warm. We will have a follow-up communication with consolidated report from conclusions of these workshop, but not only that, but also the other workshops that are taking place within this week. We will let you know on how PrimeWater progress, and also to I'd like to let you know that well, our consideration is that this discussion should be continue even after PrimeWater lifespan. So IWA took this very interesting initiative to set up a new working group under her auspices on Earth observations and how Earth observations can actually be implemented for water resources management. This is a very interesting platform for collaboration and discussion. Feel free to join this newly set up working group, a very interesting theme, and that will give us the opportunity to keep these and discuss those issues all the way. So that's from my side. Thank you again all. Samuela, the floor is yours for closing the workshop.
Thank you, Apostolis. And once again, I would like to thank all the participants, panelists, and moderator for this very interesting session. We will meet again tomorrow with a session on the energy sector, and tomorrow's session is at the same time as today, so very early for UK time. But so we hope you can join us tomorrow as well, and on Friday when we will focus on amenity recreation and the aquaculture. You'll find all the information on the chat on our website. So thank you again to all, and I wish you a nice rest of the day. Thank you so much.
Bye-bye.
Bye.